Hi guys, BuildZoid here, and today we're going to be disassembling and taking a look at this card right here. So as you can clearly see, this is a Titan X, which, yeah, this is a Titan X Maxwell. It's a bit of fan mail I got, so huge thank you to the guy who sent this over, because, yeah, it is dead though. He didn't send me just a working Titan X. This is a Maxwell Titan, which I think is the last time you could get a Titan with a non-reference cooler. And I think the way this actually worked is you got the card, like you got a reference card, and then you got the cooler separate, and you had to put it together yourself. Um, so yeah, and I think like EVGA and Zotac offered those options, and that was it. Anyway, yeah, so we have a Titan X here. It doesn't work. I don't remember why it doesn't work because, well, I decided I wanted like he sent the cards in ages and ages ago, and I've been kind of stalling out on emptying the PO box. So I've completely forgotten about that. A, he sent a Titan X. B, what was wrong with it? Um, but I actually think like the fact that I don't remember what's wrong with it is a like a good thing, because that means I get to go through the entire adventure of discovering of what's wrong with it. So yeah, but first we'll take it apart. I do have the multimeter out. Hopefully we have some kind of really obvious board level defect, because that would be repairable. Because if the board is in mint condition and it still does like it doesn't install drivers or something, then it's just like, oh, okay, I guess we're screwed. Like that is by far the thing I want the least with a dead GPU. It's like if I'm going for dead GPUs, I want cards with no display output, and ideally they like shut down power supplies and that kind of thing. Um, as that normally indicates that you have some major like short circuit somewhere, and then you can actually repair something. Whereas if you have a card where it's like, oh yeah, it gets into Windows but doesn't install drivers, then it's like, oh, I guess there's probably BGA damage, there might be silicon damage, and at that point it's just like, yeah, you're not repairing that. Because the silicon is ultimately worth more than literally everything else on the card, so, um, yeah. Anyway, let's get the plastic tub for all the parts. Um, and it's not like GPUs try not to like GPU manufacturers try not to use like a bunch of different screws. And I think at this point, yeah, the heatsink should just come off. Um, oh man, this thing has awful VRM cooling. Up, there we go. There's an LED wire. I have that right there. So hopefully I don't rip that out. Oh, this is kind of crap. That felt like the plastic's kind of like the plastic was making some weird noises when I was pulling on that. Like it was like crunchy. Okay, that one came out easy. Um, okay, well, I was hoping, so this is one of the cards with that notorious two-phase that keeps blowing up. And well, that's not blown up here. There's a bunch of capacitors missing. And those were removed by the previous owner, so that's interesting. I wonder why they did that. There's probably a short circuit on Recore. Um, yeah, this this right here. Um, you know what? Like, so 980 Ti's. And this is technically a 980 Ti. So reference 980 Ti's have a tendency of blowing up their memory power delivery, or if you find a EVGA reference 980 Ti, there's a pretty good chance that like this power stage down here is going to be blown up. And I think the reason why that tends to happen is because this is the VRM cooling that EVGA equips the cards with, and it's like, yeah, uh, this isn't good enough. Anyway, let's flip it over and take off the back plate. So I'm guessing there's a short circuit on this, just because the caps are missing. And I assume the previous owner thought that like the caps shorted or something, but caps don't short. Also, all of the capacitors are in parallel on the output of a VRM, so you're never going to know which one short. Like, on the off chance that a cap did short, um, like nothing is truly impossible. Just very unlikely. The thing is, like, you wouldn't know which cap is bad. There's just no way to tell. Well, I guess you could apply some voltage and see which cap like gets hot, but yeah, basically the only way to test for shorted components is to just kind of jam power through them and hope that they um, they get hot, and you can tell which one it is shorted, because like all of your power stages are in parallel, all of your inductors are in parallel, all of your capacitors are in parallel. There's so much stuff in parallel on a GPU that it's just like, yeah, if something's not working, you're never going to be able to tell which specific part it is. Cool. Okay, so at this point, the plate should come off. The stains are normal. That's just silicone oil from the thermal pads. So that's not. Wait, did I miss one? Oh, there's a screw right here. Okay, well, I guess just the back plate's coming off. So yeah, we have thermal pads on all of the memory chips, so that's nice. And that actually helps with the memory temperatures a bit. And I think, okay, yeah, there's a bunch more screws. This one. And this one. These are, oh man, these have the protective plastic on them still. Yeah, okay, well. that's, don't they? Yeah, these still have the protective plastic on them. Well, that's a win right there. Yeah, I should have grabbed the knife. Yeah, grab the knife. Like, don't they? Yeah, they have plastic on them. Like, there's no way that's the actual pad itself. Man, but I can see why they left the plastic on there. Unless this is some weird pad. No, there's no way that's, like, pads aren't supposed to be glossy like that. They're supposed to be, well, actually, on the camera, it doesn't really look like there's a difference. But this, like, this side is sticky, and this side just feels like plastic. So, like, there's got to be plastic on there, right? Yeah. Oh. Interesting. They don't, like, it's not clear, and... These are some weird freaking thermal pads. Well, whatever. I don't really care. I don't need those anyway. Because, like, the card's dead for now, so... And I have other, like, I can replace the thermal pads, so that's not a big deal. Yeah, but those are some weird thermal pads. Kind of metal flake in that one. Don't really think that actually did anything, though. Go. And, oh no, there's one more. Alright, that's the last one. Yep. And that's the front plate. And now let's see what we can see. Okay, there's no obvious, like, scorch marks or anything. So, multimeter time. I'm gonna guess there's a short circuit on V-Core, just because of the missing capacitors. Yeah. Okay, so... to the inductor, and then to a random ground. And I think working type... Actually, that's healthy. It's 2.6. So that should work. That's fine as well. Check the shunts. That's fine. That's also fine. Where's the last one? Ah, there we go. There's one more. So I'm just grabbing the ground off of a screw hole. And that one's, oh, there's 2.6 ohms. Okay, we do have a failed power stage. So yeah, there's a short circuit from this shunt resistor through the VRM to the output, which of course there is, because it's an Nvidia reference GPU. That's just kind of how they die. So hopefully that didn't take out the core, because obviously the problem with this kind of malfunction is that now you have potentially as much as 12 volts being jammed right into the core. Even a very short exposure to such high voltage can very quickly turn a piece of working silicon back into a rock. So, yeah, this is, I am not very happy about that. That is really not, well, like, the good news is that might be repairable. The bad news is there's a pretty good chance the core doesn't work. So even no matter what I try, there's a good chance that it'll just be like, yep, this is totally dead. Um, and I know it's shorted through the core because it's reading 2.6 ohms, right? Whereas if it wasn't shorted through the, like, if we short, yeah, see? It's shorted straight through, straight into the core. And the problem is all of these inductors are in parallel, so all of the power stages behind them are also in parallel. So we have probably there's like one dead power stage on the entire GPU. Though I have to say this is actually really surprising that this didn't put a crater in the card, because I've had other like I've had a 980 Ti, and basically when that blew up in the same way where you had a short circuit from 12 volts to the output, there was just a great big crater right where that happened. I would suspect it might be this power stage just because this one, in theory, should be the hottest running power stage in the entire VRM, but that's not a reliable way of judging things. In terms of how I actually intend to deal with this is I'm going to pull all the inductors, and and then we're just going to measure which of the leftover inductor pads is still shorted, and then you just have to pull the power stage. And pulling the inductors far easier than pulling the power stages, because obviously, like, on the off chance that this is like I would like to be able to turn the card on without having to go as far as attaching an e-power. But I don't think that's actually a very likely scenario, because there's a good chance if I desolder a power stage, it'll go into some safety mode. But there's a lot of cards where you can like desolder an entire several phases worth of components and they'll still turn on. So we'll see. But we definitely, like, the thing is, inductors are really easy to replace because they just have two very large tabs, whereas power stages, they've got all the little legs on them, and it's not really legs, it's like pads. So you've got all the little pads on them, and yeah, if you pull a power stage and then you realize you pulled the wrong one, then you're gonna feel really like it's not gonna be a pleasant experience trying to put it back on. So yeah, I'm pretty hopeful for this. I might actually be able to fix this, because it's just pull inductors. That'll disconnect the short circuit, and it'll also disconnect all the power stages from each other, though. Since this is from 12 volts, which 12 volts? That's, I think, one of the, I think that's the 8 pin, right? No? Yeah, okay, so that's the 8 pin. Whereas this other shunt over here is for the 6 pin. Yep. And this shunt over here is for the PCIe slot. Yep. So, because this is going to the 8 pin, I do believe there's going to be like 3, 4. Wait, how many power stages? I hate these VRMs from Nvidia where you have 1, 2, 3, 4, 5, 6, 7, 8 power stages for your 6 inductors. So the way this actually works, the really weird power stage configuration, is that they actually use the extra power stage for current balancing the various power inputs, which is just like, why didn't you just build a bigger bloody VRM, man? Like, come on, you've got the extra power stages. Take some load off of the existing circuitry. But it's Nvidia, so what did you expect? Anyway, yeah, but the thing is, I'm pretty sure this shunt feeds like a bunch of these power stages, and we've got these little, I do believe those would be the 12 volt like input capacitors, right? I mean, we can just check them, and yeah, that one's shorted, so that's 12 volts. That one's also shorted, and that one's shorted too. And this one isn't. So this is, I think that would be the option power stage, where that's the one. So we have these 3, and they're attached to the 8 pin, and they're all shorted because they're attached to the 8 pin. Now this up here, I'm going to assume goes to this. Okay, that one also is fine. I have a couple going to the 6 pin, obviously. And that one looks like, I think that's the PCIe slot, or actually no. Well, I mean, there's better ways of checking this. Like I can just go to ground. Okay, so that's the ground side. So now I'm gonna go with one probe on the, no, that's the wrong probe. Go one probe to the PCIe slot. And then I'm gonna go to this side of the cap, and that's not connected. But that one is, so I was right. This one's PCIe slot. This one is 6-pin, 6-pin. So we've got 6-pin, 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 PCIe slot. And then this, I think, is also 6-pin, right? Like, we can just go to the 6-pin, can't we? Yeah, so that's 6-pin. That's not? Really? Oh, I guess that one's the disconnected one then. That should be one of the option power stages. And that one's connected to the 6-pin. One's also connected to the 6-pin. And this one's not. Okay. So basically, it should actually, since it's just like we already identified which power connector is shorted out and which input caps are shorted. Just want to double check. This would actually be simpler. I don't need to even pull all the inductors. I just need to probably pull like these 3 down here, and it'll tell us if it's dead or not. And the funny thing is, because the PCIe power is up here, right? Like that's the one that runs off of the PCIe slot. If I pull these 3, this should still turn on. Because as far as I know, Nvidia cards boot with their PCIe slot power stage. Like that's one of the other reasons why they have this really convoluted power delivery setup, where it's like, oh, we've got power stages going freaking everywhere. Is because they'll actually boot off of your PCIe slot. So if you don't plug in your 8-pin and your 6-pin, you'll get that message like, yo, you need to plug in your freaking power connectors. But you don't get that on AMD cards, because on a lot of AMD cards, the entire vCore VRM is connected to the power connectors. So if you don't plug them in, the card just doesn't turn on, because you can't turn on if there's no power going into the vCore VRM. So, yeah, so I'm actually really, really quite hopeful for this. Like, this shouldn't be too bad, because basically just desolder these 3 inductors, which shouldn't take that long. And yeah, I'm not going to be doing that in this video. I think I'll probably just do a live stream of trying to repair this thing. And then maybe archive that. Actually, I'll probably not archive that. But if I do manage to repair it, there will be a follow-up video with like, hey guys, I managed to fix the card. So yeah, that's the Titan X. The cooler for this thing is adorable though. Like, this is such a... Like, when I first pulled this out of the box, I was like, why did I agree to somebody sending me a GTX 960? Because this thing is tiny compared to, like... See? It's a really tiny little card, as far as I'm concerned. With a great big chunk of silicon. So... Yeah, anyway, huge thank you to the guy who sent this over, because, well, hopefully I managed to fix it. Even if I don't manage to fix it, you know, fun little... project, and I guess I can use it for spare parts. We have some pretty nice capacitors. I don't really have an idea what I'd do with the inductors or anything. I guess I could practice swapping out MOSFETs on this, because we do have just like the memory VRM, and one thing I've always wanted to try is like swapping out MOSFETs for VRM upgrades on like low-end hardware. And it's just like, yeah, but I need a practice target, and this could be a good practice target for that, because it's just like, well, if I don't ever get it working, there's no reason, like, the memory VRM should still run, so I just need to disable, like, if I don't get it to boot, I just have to disable the vCore, and then we can use it for, like, I can still, like, the memory VRM should still be fine. Like, this will boot if the rest of the, or probably that should still start, assuming the rest of the, even if the vCore isn't running. So, yeah. Anyway, and if I do get this up and running again, then it'll probably not, like, the thing is, the reason why this VRM has such a tendency to die like this, where you have a 12-volt short circuit to the output, is because this is a terrible VRM, and this is a giant 28 nanometer core, so this thing pulls, like, a lot of power, and it pulls a lot of power at a relatively low voltage, so that's a lot of current, and this VRM just inevitably dies after, basically once it gets outside the warranty period, right? Like, Though if you overvolt these, they'll actually die before they go outside the warranty period. It's kind of the thing is like if you have a really overpowered VRM, it is extremely unlikely that it'll fail like ever. Um, and then of course you have Nvidia GPUs where you can literally find stacks upon stacks of cards with this PCB on eBay with dead V-Core power stages because Nvidia. So yeah, anyway, I will actually end the video at this point. So thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. Again, huge thanks to the guy for sending this in. This is going to be a really fun project. What else was there? If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the AHOC Teespring store where you can pick up shirts, stickers, posters, you know, the usual YouTuber merch. There's a really cool new shirt design about memory overclock, like that's themed, memory overclocking themed. So you might want to check that out if you've not seen it already. And there was one more thing. Right. So this is fan mail. I do take fan mail. I have a P.O. box. You're going to have to send me an email to buildzoid@gmail.com about what you want to send in, because I'm not just going to take any random GPU manufactured in the last 30 years, okay? Like, I'm very specifically, like, I'd prefer, like, cards, like, repair attempts and sort of high-end cards is what I'm more interested in. So, yeah, and this is an interesting card just because it comes with the cooler. So, anyway, I will actually end the video now because this isn't going anywhere. Yeah, so thank you for watching, and goodbye.